Okay, so let's have now our part 2 sample problem. Wherein for this sample problem, we have a baseball is thrown with an initial velocity of 100 meter per second at an angle of 30 degree above the horizontal. So let's first answer letter A. What is the initial vertical velocity? And so for the letter A, if we're gonna solve for the initial vertical velocity, that would be uy. Okay, uy, that would be the sine of an angle multiplied to u. Okay, multiplied to the uh, initial velocity. Now take note that initial vertical velocity is different from the initial velocity. And so here we have uy, that would be sine 30 degrees multiplied to the u, which is 100 meter per second. And therefore we could now say that uy sine 30 is zero point 0.5 multiplied to 100, or use your calculator, that would be 50 meters per second. Okay, so that is our answer for letter A. Now, how about for letter B? For the letter B, we are asked for initial horizontal velocity. Now, for the initial horizontal velocity, the label for that is ux. And with the formula again, we have the cosine theta multiplied to u. And so we have ux, that would be cosine of 30 degrees multiplied to 100 meters per second. And if you try to press your calculator, cosine 30, so we have cosine 30, that would be root 3 over 2 times 100, and that would be 86.60. Okay, 86.60. Okay, if you write here 86.602, but rounded off to two decimal places, we have 86.60 meters per second. Okay, and so that would be our ux. Okay, how about now for letter C? If we're gonna look for letter C, the question here is, what is the vertical velocity of the ball at the maximum height? Now take note in our projectile, if you're gonna look at our projectile here, right? Remember this equation, the Vy is 0, right? So here, for our letter C, the maximum height for the projectile would be 0 meters per second. Okay? So we have here the velocity, vertical velocity at max height. Okay? Now, how about for letter D? So let's look at letter D. What is the horizontal velocity of the ball at the maximum height? Now take note, the horizontal velocity is not changing. So even at the maximum height, okay, the Vy is 0, but the Vx is consistent all throughout from the start to the end, right? So that is consistent. So whatever your vertical velocity, it does not change. It is consistent all throughout, okay? So here we could see that the value of our Vx at the max height, so we have Vx at max height, that will still be 86.6 meters per second. It's constant, it is not changing. Okay, now how about for letter E? Okay, how about now for letter E? What is the time of the ball to completely reach its maximum height? So that is a question. What is the time of the ball to completely reach its maximum height? So remember this equation, right? So if you could remember here, this is how we derive it, right? So the maximum height, the vertical velocity is 0. So we can derive here for that time. So we have your time. Now solve for the time. Time now is negative uy over g. And so solving for that, this is the uy, right? So we have 50 meters per second divided by negative 9.8. So we put negative. Okay. So that is 50 divided by 9.8, and then 55 point 5.102 seconds. So we can round it off at 5.10 seconds. Okay, so that would be the time. Okay, now how about for letter F? Let's look now for the letter F. What is the total time of the ball before it will reach its original height? Now, so if you draw the projectile, the time going to the maximum height, this is the time, and the time going down would be the same. So that would be the time, the total time would be twice the computed time. So we have 2 multiplied to 5.10, 5.102 seconds. And so 2 times 5.102, that would be 10.204 seconds, or we better round off to two decimal places, 2.20 seconds. Now, take note that if we are asked for the calculations, we must use up to two decimal places because we are usually asked for two decimal places. So when we do calculate, we include up to three decimal places, and then we will gonna round off the final answer. Okay, so let me just hide this. Next, how about for letter G? Now, for the letter G, how far from the throwing point will the baseball attain its goal, its original level? So here we're gonna talk about the range. So from this point up to this point. So here we talk about the range, right? And so we have here the ux multiplied to t, if you can still remember that, right? So we have here range equals to ux multiplied to twice the half of time. So here, okay. So let's go now here. That would be range. What is ux? So ux here would be uh 86.602. This is the value. This is the value. Okay, this is the value multiplied this meter per second. Okay, meter per second multiplied to 10.20. This is the value. Okay, so we have 10.204 seconds. And so what will now be arranged? That would be times 86.602, 883.68. Okay, so we have 883.686 meters, or let's try to round it off to two decimal places, 883.69 meters. Okay, so that would be our range. Now, if you take note for the letter H, okay, for the H, I, J, and K, so you may compute that with a formula, but what I want to say here is that in the case 2 of the projectile, we're gonna have the same final horizontal velocity, that is still 86.6. We have the same final vertical velocity, which is 50 meters per second, and then we also have the same final velocity. Okay, and then also we have the same angle, which is 30 degree. Okay, so that would be our answers, but if you want to know how it is done, you may proceed with the video. But if you think you're already enough for this, you already know, then that's it, no? That's it. So whatever the angle as well as whatever the angle as well as the initial velocity on the start of the projectile, that would be the same angle at the end of the projectile. Okay, and also the same magnitude in terms of its final velocity. However, that only applies for case number 2. Okay. Now let's try to solve first for the letter H. Okay. So for the letter H, what is the final horizontal velocity? It doesn't change. So Vx is still 86.6 meters per second. Now, how about for letter I? What is the final vertical velocity? So you can have Vy is equals to Uy t Uy plus gt. And so we have here the Vy. What is the Uy? The Uy is 50 meters per second plus, well, negative 9.8 multiplied to the time, which is the whole time, 10.20 seconds. Here we use the whole time of the projectile, the capital T. Okay, so if you're gonna compute for that, that would be 50 minus 9.8 times 10.204. This one is 204, I think, 204 seconds. And so that would be 99.999, and 50 minus 99.99, and the Vy now here is negative 49.999. Okay, and then we round it off to Vy is equals to negative 50 meters per second. Okay, so notice that it is still the same. Now, how about for the letter J? What is the final velocity? So for letter J, we're looking for V. And we all know that we have here the V, which is equal to the Pythagorean theorem, which is Vx square plus Vy square. And if you apply for that, that would be 50 square, okay? Vx, I mean, Vx first. So we have 86 point, I think 67, right? Square plus 50 square. So V, that would be equivalent to almost 100 meters per second. Okay, so notice that still we have the same magnitude for the velocity. However, if you're gonna imagine that, this one will be your projectile. Okay, okay, and so this one is your Vx, this one is your Vy, and then this one is the V. Okay, now how about for the angle? For the angle, it's the question. At what angle? Okay, so at what angle? Remember, we have the tangent, right? So tangent of theta is equals to Vy over Vx, and therefore we're gonna derive that with the arctan of Vy, which is 50 over 86.67. It's negative. So our angle here would be the arctan of, let me just compute it again, 50 divided by 86.69. Okay, so overall, that is, if you're gonna round it off, that would be around 29.975, and somehow that would be equal to 30 degree. Okay, so again, for this item, whatever the initial velocity going up, that would be also the final velocity going down in terms of its magnitude. Now, I forgot this one is negative. This one is negative. So what does it mean? The angle is in quadrant 4 or below the x-axis. That's why it's negative. Okay? So I hope you do the case number 2. And this is the procedure usual the usual procedure for the case number 2. And you'll try to solve other problems in our problem sets so that you can encounter more problems and more the more you get acquainted with the problem solving, the more it will be easier for you to analyze this projectile. But then again, these are the basic or the things that you need to know in order for you to solve projectile case number 2.